Welcome back to this fighting game series. You are currently in coding section, and today we would finally be making our game interactive. We will move the buttons and have our player move, attack and jump. So I hope you're excited because today our player gets to do something we actually tell it to do. To start, we get to our player character class and create a function to update the player state using the character state enum. This function changes the player state variable and the sprite animation. We can then go to our actions controller component and add our player component so that we can directly call the update function. Within each of the action functions, we can directly call the update state and pass in the state we want to update, and the player makes that movement. If we change the character type, we get the same results. Looking at this, we will notice that the animation performs at the same time for all the sprites. So all players will perform all actions at the same speed, and this is not looking very nice. I would create a sprite settings class that would hold settings for each action performed by each player. And since each player has different states, we would need settings for each of those states. So I will have a state sprite settings also. This would hold the time to animate that action and the anchor direction that will best suit that state. The player sprite settings will then hold the setting for each of these states. I will be pasting a long factory constructor here which contains the value for each of these states for all the players. This script is in the starter project, so you can just find them there. The values was gotten by setting the time and the anchor on each sprite and seeing if the position feels realistic for that value. You can try to switch out some of these if you want a faster or more slower animation on any of the sprites. With this constructor, you can set the character type and get the settings for all the sprites for that character. I would also be adding a function. This function will take the character state and return the sprite settings for that state. This will be very useful when changing the states in the player character component. Within the player character components, we can add the player sprite settings. In the constructor of this player component, I will set the sprite settings using the factory constructor. That gets the player sprite settings from the character type. So whenever I want to set the sprite animation, we just get the settings for the state we want to animate and then set the time and the anchor. I will do the same for the update state function. Once we complete this, we'll face another problem. The player freezes in the same place after performing the action. We need a way to know when the player has completed the animation and then return the player to the idle state. For this, I had to come up with a simple equation to help calculate the animation time. This time is saved in the action timer. Then within the update function, this timer reduces, and when it goes to 0, the user is returned to the idle state. Action timer is equal to the time in the sprite setting multiplied by the number of frames. So after the user attacks, it goes to the idle state. I also noticed that once the game starts, the user does not enter the idle state. To fix this, I just set the initial action to 1 and everything was okay. The next action to work on is the movement. For that, I will set a variable called isMoving, then a function to start moving with a set direction, and another function to stop moving. The controls for movement will allow the user to hold the button for movement and release the button to stop moving. So I'll change these functions to move start and move end. On the movement controls button, we would need to add the player component so we can control the player. These controls will then happen in the function. We can now add the functions to the button. In the player update function, we will check if the action timer ends and the player is still moving. Then we set the state to moving state again. This is to keep the movement continuous. When the movement stops, we reset the action timer to 0 so the animation stops immediately. To make the player move across the screen, we would also add a function to update movement. This would add the position of the object so that the player actually feels like they are walking. The movement animation seems to continue even after the user releases the button. So within the move stop function, I will call the update state to return the user to an idle state. Now the player returns back immediately the user releases the button. At the movement, if we walk back, the user does not turn to face the direction they are walking in. So within the move start function, we check the direction and then flip the sprite animation whenever the direction of the button doesn't align with the direction the player is facing. The movement looks better now, and there's still one more thing to address. The movement speed for all players is currently set to a constant value, but we should have some varying speed for each character. For example, the samurai should not walk at the same pace as the wizards. To store the stats for the individual players, I will create another class called PlayerStats. This would hold the attack for each of the attacks and the player resistance, the walk and run speeds, as well as the jump power and distance. Let's add the constructor for this. This class would have a factory constructor that takes in the player type and returns the player stat. I have some values that I've already set up for each of the players, so you can copy them and they are in the starter file also. These values are mostly random, so feel free to change anyone if you feel any player should have more attack power or more speed. We'll have to add the stats to the player character class and then update the movement function to use the walk speed from the stat. With this change, each player has their individual stats for each action. Next, I want the power up button where the user can double their attacks and run across the screen. To do this, I would add the power boolean variable. Then, we will also have the power up function. Let's add this to the button. We can now update the speed in the movement function and use the run speed when power up is active. Let's also change the animation on move stats and use the run animation when in power up. The next action we would work on is the jump action. For this, we would need a vector called jump velocity. This would serve as the force pushing the player upwards as they move. We can now add a jump function that updates the state to a jumping state and also sets the jump velocity using the variables from the PlayerStats. Within the update movement function, we would add the jump velocity to the player's position. To make the jump feel natural, we would have to reduce this velocity continuously if the player is above the ground. For this, we'll need to get the ground level. Let's create a class called GameConstant that would hold constant values like this. When the game loads, we would have to set the ground level using the screen size. So back to the player character component. If the position is above the ground level, we would update jump velocity, and if it is on the ground, the jump velocity will be reset to 0. With this, we can add the jump function to the button. Let me place some comments in the code so that it's easier to read. Let's add a variable called jump time, and to store the time it takes for the jump animation to complete. I want to use this value in the jump action because I don't want the player to jump and have the animation finish while they are still in the air. Then in the update movement function, we include the jump time in the equation. And frankly, I don't know if this is correct, but it worked. When the player jumps, we should prevent any other jump action in the air. Let's change the character to a skeleton. We don't have the jumping sprite for this, so it actually fails. So let's disable the action for skeletons. In the enum, I would create a boolean to check if the character is a skeleton. And then, if the character is a skeleton, we prevent the jump function. With this, we have all our actions successfully attached to the buttons. Alright guys, we've done a lot in this video and I want to thank all of you who are still here now and appreciate your audience and would be happy to bring more stuff like this. So if you have any game ideas in mind, you can just drop it in the comments and I'll look into it, and hopefully we'll get a video for that also. And see you guys later.